still talking about proportions. A proportion is two equivalent fractions. Two equivalent fractions. All right, we also have what's called the cross product property. And the cross product property states that the cross products of two equivalent ratios are equivalent. So let's look at an example. Let's say I had 24 over 2. So my first ratio or fraction is 24 out of 2 is equal to 12 over 1. Now, what the cross product property says is that if I multiply my cross, or go across and multiply, for example, 12 times 2 is 24. 24 times 1 is also 24. So because the cross products are equal, then this is a correctly set up proportion. If there is a missing part of a proportion, we can use the cross product property to set up a proportion and solve for x. So here's an example of a proportion. 3 out of 8 is equal to something out of 24. So remember, these are two fractions that you want to equal each other. Okay? So what you could do is use the cross product. So 3 times 24 is 72. Now using the cross product property, you would ask yourself, okay, to complete this proportion, 8 times what is 72? So the answer would be 9. So x would equal 9 because 8 times 9 would also be 72. Now, there is another way to solve proportions. It's called cross multiply and divide, of which we will do on example 3. So we are looking for a missing value, x. So what I would do first is go across and multiply. So 8 times 6 is 48. Now, what I would do then is divide by this number I haven't used yet. So I would take 48 and divide by 10, and that's going to equal 4.8. So my missing value to make this two equivalent fractions is 4.8. When setting up a proportion from a word problem, first I have to label my fractions. So before you even set up any numbers, you would want to fill out the labels of what you are comparing. For example, students to teachers is equal to students to teachers. Now in proportions, you want the same thing across from, the same label, I should say, across from each other. So students across from students, teachers across from teachers. All right, now let's really look at a full word problem example. So Megan can make 12 cupcakes for $10. How much would it cost her to make 42 cupcakes? So what we would want you to do first is to label the proportion first. We are comparing cupcakes to money. So I would label, this would be cupcakes, over money. Now because I put cupcakes on top here, then I would also put cupcakes on top here. Cupcakes to money. Okay, now once you have your labels, the next part would be to plug in the values based on the question. So we are comparing 12 cupcakes, 12 cupcakes, I'm just going to label it cakes, and we're comparing that over $10. Okay, now we are trying to make another equivalent fraction with comparing how much it would cost to make 42 cupcakes. Now if you look at your units, because 42 is also cupcakes, we would put it on top because the same thing goes across from each other. solving for the missing value. Okay? So my first step would be to cross multiply. So I'm going to go across and multiply 10 times 42. So 10 times 42 is 400. Excuse me. Whoops. Let's move over here. Is 420. Okay. Now I'm going to take 420 and divide by the number I haven't used, which would be 12. So 420 divided by 12. Okay. 12 goes into 42 3 times. 36. Bring down my 0, so it'd be 35. So my cost for 42 cupcakes would then be $35. All right, example 5. If an architect uses a scale of 1 to 80, how tall is the actual building if the model is 3.5 feet tall? All right, we talked about this when we did ratios, where you can use a colon in order to represent a ratio, okay? Now, first I'm going to label my units. That should be your first step. I'm comparing a model building to an actual building, all right? So I would label this. This would be my model. This would be my actual. This would be my model. This would be my actual. Okay? Now, to go and plug in our values, this is my ratio. 1 foot on the model equals 80 feet in real life. So then I would plug it in 1 over 80. 1 for the model is 80 to the actual. How tall is the actual model if the model is 3.5? So because 3.5 is the model, I'm also going to put that on top here, okay? This would be the model. I'm just going to use M, model, actual, and I'm solving for the actual. So I'm going to go across and multiply 80 times 3.5. And we are going to get 280. So 80 times 3.5 is going to equal 280. Now, I'm going to take that and divide by the number I haven't used, but dividing something by 1 isn't going to change it. But just so you can see what it looks like. So that means that my actual building is going to be 280 feet because I cross multiply and divided by the number I hadn't used yet. All right, example 6. We are going to just do one example and then I'm going to have you guys practice some on your own. All right, we're going to compare 24 pizza sticks and 2 tablespoons of garlic to 60 pizza sticks and how much garlic it would take to make that. Okay, so first we're going to, of course, label our parts. So we're going to label this pizza over garlic. And pizza. Notice I'm still putting the same thing across from each other. Okay, so 24 pizza sticks over 2 tablespoons of garlic. And I'm going to compare that to 60 pizza sticks. And because 60 is still pizza, it goes on top. So I'm solving for x. So I go across and multiply 60 times 2, 120. Then I'm going to take 120 and divide by the number I haven't used yet, which is 24. So 120 divided by 24, and you're going to come up with 5. All right, now I would want you to finish the table So please use proportions to fill in the missing 3 sections.